Hi everyone. What we want to do here is go ahead and do a little one of the add-ons. And first off, let me apologize. I am kind of sitting in an airport right now, so if you do hear some background PA announcements, I apologize. And I know this mic isn't as great as my other one, but hopefully we can bear with. It should only be about a 10-minute video or so. Um, so what I want to do is address in the assignment 3, the very first add-on here, which is to copy the structure for the entire length of the final pavilion. In the videos, we made only a single bay, determine the necessary spacing between the bays and the total number of bays, and go ahead and copy the structure multiple times over. So, here we are looking at our form. This was just kind of like a generic rough form. Here was the mapped on bay, and this is one complete bay. And what we want to do is copy this multiple times down the road to mimic our final structure. And I'm not too concerned about how many times you copy it, so long as you go ahead and have some sort of adjustable slider so I can copy multiple times. So first thing I'm going to do with this definition, I'm going to go ahead and just hide this surface. And there we go. The next thing I want to do is I need to copy all of the items, or I should say group all of the items that I want to copy. And that would be the 2 structural pieces here, as well as the 3 individual bays. So what I want to do is go ahead and in my kind of built definition here, I want to go ahead and kind of start a whole nother line here, bringing some of this information down. And if you go kind of in the middle here, where it's step 02, you'll see at the very end the result is this lofted form. And these lofted forms are actually the shell domes themselves. We want to go ahead and bring those down below as wireless receivers. To do that, those are just lofted forms. A B-rep is the most kind of generic version to kind of contain that. So we're going to go underneath parameters, geometry, and B-rep. We're going to go ahead and contain that. I'm going to go ahead and relabel these. Then I went ahead and made it called it dome shells. Wire display, make that hidden, and go ahead and bring this down below. I'm also going to go ahead and just grab another one of these panel tools, and I'm going to go ahead and copy and paste it.
Again, flight 780 to Tulsa has moved to gate C27.
There we go. And you're going to want to go ahead and add in the text about what we're going to be kind of achieving here. So here's the wireless receiver for the shell domes. Next thing I need is the actual structure pieces. And that's coming out of these 2 joins happening at the end of step 04. So these 2 join components are where those are coming from. Let's go ahead and again bring down a B-rep. Go underneath parameters. Go to geometry and B-rep. I'm going to go ahead and relabel one of these. I'm also going to make it a wireless receiver while we're at it. Wire display hidden. And copy paste it and relabel the second one now that we've got that set up. So Control C, Control V, copy paste. Go ahead and right click and relabel this as structure B. There we go. And wire these in appropriately. Again, we're going to go ahead and bring these down below. And I'm also going to go ahead and turn off the old components as we kind of continue along here. So we're going to go back up, just select everything, right click, preview off. Go up here, select everything, right click, preview off. There we go. Now that we've got them all kind of together, what we want to do is actually group them so that everything kind of is acting as one component. And I'll explain why we're going to do that in a second. But in the meantime, we're going to go ahead and use a group component. And you can see you can find that underneath the transform tab, to utility, and then group. You'll see the opposite is ungroup. There we go. Now we're going to go ahead and wire all these together, holding down shift as we wire them in. And there we go. So now they're all grouped together. What I want to do is I want to create a bounding box so I know the exact width of this group, and then I can know how far to copy and paste each of these items based off of the overall width of the object. So again, we're going to go to create a bounding box. Go to your surface, go to, primitive and bounding box. Go ahead and connect the group into the C, which is the objects to contain. There we are. And you'll notice something funny kind of happen. You'll see we actually have groups inside of groups, or multiple groups. If I hover over the B output, I actually get 3 individual ones. What's happening is that the 2 structures and the first shell are all in one container, but then the 2 other shells are each in their own. And that's because they're contained in different lists. If I go ahead and drop in a panel tool here, you'll see that this has the kind of sausage wires, and they're in individual lists. The first item has a 0, and then the 1 index and the 2 index for the path locations. You'll see structure A and structure B only have the 0. So that's why structure A and B get joined together in one single bounding box, the first open B rep gets joined along with that, and the two other ones, which have different path locations, actually get their own bounding boxes. So what we want to do is get rid of these sublists or have them all the same path location up here. And we can do that just simply by flattening things. We can either flatten coming out of the actual container here, or we can flatten going into the group. By flattening coming out, there we go, they're all under the same path location of 0. Now all these items have the same path location, and therefore they get all put into one giant bounding box. Now if we can measure this bounding box from the lower left corner to the lower right corner, we can go ahead and know how far to move this. So to do that, easy enough, what we're going to do is take this bounding box and find the corner points of that. So what we want to do is go underneath our surface, go to Analysis, and Box Corners. Here we're going to run our resulting bounding box into the box corners. You'll see as a result we get 8 corner points of that bounding box. They're listed as A, B, C, D, E. We need to figure out which two we want to join, and we can either join these two here or these back two, these top two, any two that are kind of dealing with the width of this single bay. Let's go ahead and figure that out. The best way I like to do this is just drop in a single point container, select it so that's highlighted, and just start wiring things in. And you'll see because it's selected green, that item should turn green on your Rhino screen, and we know which ones they are. I don't like A. I'm going to go ahead and try B. Well, that looks pretty good right there. I'm also going to try C, and there we go. So we know B and C will work out well. So we need to measure the distance between B and C. I can delete out this point container. I don't need it. We know B and C is going to work. So what we're going to do is go to Vector. We're going to go to Point and Distance. We're going to measure the distance between B and C. We get a final result, in this case, of 5.727662. We're going to use that as a Y displacement along the Y-axis. So we're going to go underneath Transform, Euclidean, and Move. The geometry we want to move is the entire group, like so. Now it moved it up in the Z automatically because the transform by default has a Z unit vector of 10, 0, 0, 0, 0, 10. We want to convert that into a Y vector based off of this distance. So we're going to go to Vector. We're going to go to Vector again. We're going to go to Y unit vector. We're going to run this distance as the force of that vector and use that vector as the translation vector there. There we go. Okay, so we've now created one that works out really well. I'm going to go ahead and hide some of this old data. Okay, but we'd have to kind of keep piggybacking. We'd have to do another move and move this new one, another move and move this new one, and so on and so on. What I want to do is actually do all these in one operation. So what I need is a series of distances. Let's just say that for now, just for the ease of this distance was 5. I need to move one unit at 5. The next one I want to move to 10, to 15, to 20 for the number of bays I want. So what I want to do is I want to create what's called a series of distances. So what I'm going to do is go underneath Sets, Sequence, and Series. The S is the starting value of the series. We want to go ahead and move the first one by this distance. So we're going to hover this distance of 5.62 or whatever it is, 5.7276 as the starting point. Then the N is how far do we want to move each one after that. That's again the same distance. We want to move the first one by 5, the second one by an additional 5, third one by additional 5, so forth. So the step size, the N, is that 5.72 value as well. So the first one's going to be started at 5.72, and the second one is going to have an increase of 5.72, and the C is telling how many times I want to do this. Well, we could count the number of bays we have and tell it the number of bays, or we can just do a slider and make it kind of dynamic. Let's go ahead and drop in a slider. We can go underneath parameters, input, and a number slider. I'm going to set this, double click on it, to integers. I'm going to do a minimum of at least 1 and a maximum of, say, let's say 10 for right now. I'm also going to call this number of bays. There we go. And we're going to go ahead and run this into my C input. Now you'll see as a result what we get is just a set of numbers that increase. Whoop, we only have 1 for right now. But as I increase this, you'll see each one of these is adding that value of 5.72 to the previous one. So we started, the S input to start was 5.72. That's what goes in the 0 input. And each one after that is increased by that 5.72 value. There we go. Now we've given it 5 different values. So we can give it 5 different forces, which means it's going to move at 5 different times. There we are. Now because we moved it 5 different times and we had one to start, the result is 6 of these bays. 1, 2, 3, 4, 5, 6. So what we really want to do is take this number of bays and subtract 1. So if we want 5 bays to end with, we only want to actually move it 4 times. So let's go to C input, go to expression, and type in x minus 1. There we go. So now it's going to count 4 of those, resulting in 5 because we had our original one like so. There we go. So now what we've done is gone ahead and copied that using a series and a slider. I can go ahead and delete out the panel so I don't really need that. And I can make it dynamic. So I can either add more bays or subtract bays. Okay? That's one way we can go ahead and make this a dynamic definition and create multiple ones. Now, one thing I would worry about is you can see when we go to 1, because we have an expression of -1, essentially that creates this no series at all because the count would be 0. So what we might want to do is go back and adjust the minimum one to be at least 2 bays. There we go. So now by at least having 2 bays, we don't have run into any errors downstream. So now what we want to do is go ahead and group all of this, or group similar things, write your little definition within here, and create kind of as many or as few bays as you need. You'll notice too, as the second part of the add-on, if you want to do this, is to create a B bay. You'll notice that every other bay is different. This is what I'm referring to as an A, B, and B, an A bay and B bay. Within here, it's only the second, third, and fourth openings create the actual bays. So what I'm getting at is we need to create shells here, 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 and here. So you need to go ahead and find the intersections, create the shells, and copy from there on. I'm not going to do a definition for that. That's an add-on you guys can try to achieve on your own. But go ahead and annotate this add-on for your final assignment. If you have any questions, as always, you can email me, melmstrom.1, and we can work our way through it. Good luck.